All right, welcome to a video on rigging stairs. So stairs, you want when you rig them up, you want this, let's say this landing to be level. Maybe not. I mean, you might want to be able to rotate it so it goes up a shaft and then not. But for the simplest scenario would be something like this. So that's your stringer, and this is flat bar. This is the simplest one I could remember. It was up in it was Mandible Canyon. We did a set of stairs, and most of the components were all flat bar, 1/2 inch by 12-inch flat bar, which is useful for this because it's uniform, right? There's no different weight in one end to the other. The whole plate. This was a one solid, basically 1/2 inch by 12-inch solid plate, so it's uniform. And then to calculate the location of where you want this to go, we need to locate the center of gravity, because the center of gravity is always going to be below the hook. So VK, say we slung it up like that, and let's say the center of gravity was here. Control H. Looks pretty good, but it would end up being, you would end up like that. That's how it would land, right? Because as soon as you pick it up, that center of gravity is always going to be below the hook, all right? So what we want to do is we want to pick it up so it's level. So what we got to do is locate the center of gravity. So that the easiest way in the field, on this case, because it was all uniform, is just go, okay, it's center this, control center that, and then control K. So basically all we're doing is getting a line, and we're going to pull this length. Because it's uniform, we can use the length as the weight. If it was a different, let's say this was 15 pounds a foot and that was 10 pounds a foot, then you'd actually have to calculate the weight of that piece and the weight of this piece and use those in the weight measurement. But V, control K, we don't have to because it's uniform, control K. So this is the kind of a rough center of gravity of this piece, and then this is roughly the center of gravity of that piece. And then we're going to measure this one along this, right? So we have we're going to replace the weight with, and we're going to replace the weight with. So distance and diagonal distance. So what happens now is the center of gravity is going to be somewhere along this line. We need to know how far away from this point it is to the center of gravity. So we're going to do a calculation. I already did T control right there. So let's do this. I don't like that color. 86.6 D1. So that's the distance times the weight at the end, which is 117.93, divided by the total weight, which is 61.75, plus 117.93, right? And then you do the calculation with 56.85. So V, JS, JD, 56.85. 56.85, enter, and that is the end of that, right? So let's put a point there, and that's going to be a really rough center of gravity. Rough, maybe not. It's going to be very close. And let's actually see how close. It's not exact because this is actually a triangle, and the arm, the distance away from the center is greater. It's going to give you more rotational force, I guess you'd call it, more leverage away from more rotation. And then this one here is less, right? If they were equal, then it would be equal, but this one's less. So there's a little bit more sticking away from the center, so that not truly the center of gravity, but for slinging the stairs, it's going to be close enough. And then, so what's going to happen now is no matter what, if that's the center of gravity and you rig your slings like this, they're going to end up swinging. This will end up underneath there. It'll end up like Control H. That's how this will end up being under there, and that's how your stairs would hang, right? So what we want to do is we want to get that slings exactly where they're supposed to go. So the main principle here is you're going to go from the center V, J, A, and then we're going to do a perpendicular to the landing because that's how we want it to land. So as we're hanging it, this is level. So we're going to just pick a sling length, K, J, D, 60 inches. To say that's how much after you choke it, after you choke that, that's how much you got left. Enter. So what we want that to do is land here, somewhere here, right? So A, and it's kind of low, right? Kind of want a little bit more of a sling angle. So what we'll do is we'll take this and move it downhill, let's say 1 tread. All right, I kind of like that sling angle there. So that's where she lands, right? That's our fixed length. Now let's say we have a 8-footer. Looks like we're going to want a little bit longer, so we're going to have whatever the choke is plus 8 feet hanging out, V. And we're going to pick that spot right there. JD 96. And we're going to put that, see where that lands, right? It's going to land over there. Don't really need to do that. Well, we know we're going to measure how much is left over, how much after we sling it, and we know it's 96. So what we're going to do is we're going to swing an arc from here at 96. So A, C, 96. Right, and then where that intersects there, that's going to be the location for this. And we can swing that arc. Right, and then she moves right there. Perfect, right? So now we're set with the right size slings. And now if you need to hang that, the hook's there, it's going to hang directly above that, and you're going to have level stairs. That's how you do it, the simplest way. And that's, like I said, this is a uniform piece, and there's no rotation because it's just a single solid piece. Hope that helps you in your career next time you're setting stairs. Thanks for watching. Bye.